Good morning. I am Mr.DHAKSHUNHAAMOORTHY, Assistant Professor, Artificial Intelligence and Machine Learning Department. I am handling subject 21 CS 003 Mobile Application Development, Unit 2 Wireless Mobile Networks. Topic is PDCP, NAS and RLC layers. Layer 2 functions, that means PDCP layer. PDCP functions provides data transfer functions. Responsible for security functions, that means ciphering and deciphering for user plane and control plane data, integrity protection and verification for control plane data. And also it performs header compression and decompression using ROHC, ensuring lossless data transfer during handover and radio link failure, retransmit missing PDUs during a re-establishment of PDCP, timer-based discard. PDCP architecture. In this architecture, there are two sublayers. One is PDCP sublayer, another one is RLC sublayer. In the PDCP sublayer, we are having two types of entities. One is CSAP, another one is PDCP SAP. In the bearer, which consists PDCP entities. And then in the RLC sublayer, here RLC UM SAP and RLC AM SAP is mutually exchanged between PDCP layer and RLC layer. Each radio bearer is associated with one PDCP entity. Each PDCP entity is associated with one or two RLC entities. PDCP processing blocks. Here the first in this PDCP block, the first layer is NAS, that means non-access stratum, then RRC layer, then in the PDCP SDU, signaling data unit. Here it is given to the main block, where we are giving the sequence number for each PDCP SDU. After giving sequence number, we are checking the integrity protection and validation. Next, that signal is given to the ciphering block, and then we are including the PDCP header, then we are getting the PDCP packet data unit, and it reaches to the RLC AM. In the receiver end, that means in the user side, user application, everything, all the processes are in reverse order. Whatever the signal received in the receiver end, see what we are doing is the PDCP PDU. First of all, we have to remove the header, and then we have to conduct the deciphering activity, and then we are checking the integrity protection once again in the receiver end. Based on the sequence number, we are rearranging all the signal PDU units. Then we are getting the PDCP SDU. in the user application side, users a plane in which user application is the first one, and then DSLPS layer, then PDCP SDU unit, the retransmission buffer, which helps to, whenever the signal is not reached to the destination, we are using retransmission buffer, and then sequence numbering we are giving each PDCP SDUs, then header compression operation, then ciphering, then PDCP header inclusion. This header compression used by using ROSC technique whenever we are going for the VO LTP, the like voice over conferencing techniques. When we are going, we have to send a very small amount of data unit, but the header is the wider range. To avoid the header overheads, so we are using header compression to the minimum level. Header compression and decompression based on ROSC, robust header compression technique, in which the compresses header of IP packets 40 bytes for IP version 4 and 60 bytes for IP version 6 packets. We are used for applications such as VoIP, VoLTE, where the size of header may be larger than the size of the actual data. Using ROSC, the size of header can be compressed to 1 or 2 bytes. From 40 to 60 bytes of header is getting reduced into 1 or 2 bytes. A header consists of constant fields such as source and destination address, the source and destination ports, etc., and dynamic fields such as identifier or checksum field. During initial transactions, the packets are sent with a full size header and a context is established between the compressor and decompressor. Header compressing and decompression. Few more points I want to include in this. Here, for subsequent transactions, only dynamic fields are transmitted, reducing the header size greatly, the robust against bit errors, packet loss, and long round trip delay. We can able to see the diagram. Here in this diagram, the header consists of 40 bytes for IP version 4, 60 bytes for IP version 6. See, what are the fields included in this is first field is IP field. It consists of 20 bytes, UDP 8 bytes, RTP 12 bytes, payload, actual payload is 20 bytes. After doing header compression, around 40 bytes of header is compressed into 2 bytes, then actual payload is included, such a way that the header is minimized to the certain level. Here in the header compression and decompression, different ROSC profiles